Being able to automatically build containers can be life-changing to your infrastructure. I'm going to show you how you can build your very own CI/CD platform using Kestra as your platform of choice. Now, for those of you who are unfamiliar, Kestra is a workflow orchestrator that allows you to build powerful workflows without any limits. Using our Docker plugin, you'll be able to build powerful workflows that can integrate directly using Docker. Let's have a look at this example. Now, what's going on here is we have a Git repository that looks a little bit like this. Maybe this is a scenario that you might be in yourself, where you've got a Git repository with a Docker file in it. And whenever a new commit arrives in this Git repository, you want to be able to build this Docker file and maybe run it. Maybe this is, just something you want to run daily every time there's new changes. So inside of our workflow here, I've got a task here called the working directory, and we can see that over here on the right hand side in the topology view, which basically just means that all the tasks we use inside of that working directory will use a shared directory. So that means we can now use the Git plugin to clone our repository. And then we can use the Docker task here, the build one specifically, to build the Docker file inside of that to create our image, which we can then later run with the run task. And because we're using the working directory task, everything can access everything's working in the same directory, so it makes this really streamlined. So let me execute this task now, which we can do like so. And as you can see here, it's been able to clone that repository, it's able to build the image successfully and tag it as hello world. And then we can see that it runs it using the Docker run command. So if you're looking to be able to automate those steps of being able to build and run an image, maybe on a schedule, or maybe you can make it event driven, which I'll show you in a second using a webhook, you can do that with Kestra. Now, the thing that's really nice about this is you haven't had to interact with a registry. So you might, in some scenarios, you might publish your Docker image to a registry and then have a different platform, then pull that image from the registry and then run it, which can be really beneficial if you want to be able to access it on multiple servers, but you might have costs involved in hosting those images, especially if you host quite a lot of images and you're updating them regularly. This workflow allows you to just build it, and then using this expression here, we can dynamically pass the tag here to the run task, and then because it's all inside of that context of the workflow, it has access to the image already, and we don't have to use a registry to access it and pull the image to be able to run. So this works really nicely. And then the cherry on top for this workflow is we've got a webhook set up here. So that repository I showed you, I've actually set it up using a webhook. So under our webhook settings, I've said whenever there's a new change being pushed to my repository, then run my workflow. So we can test that theory by going to our Docker file here. I can click edit here and I can just say hello world from my container, like so. So now if I commit this change like so, what we'll do is we'll go back to our workflow and we'll actually see under executions, it started to run a new execution today. I can click in here and see that that execution has been triggered using the webhook. And if I go to the Gantt view, we can see it has successfully worked. We can see it built that image successfully. And if we go to the run task, we'll see that it did in fact say the correct message. And if we go to logs, we can actually filter by just the info logs and we can see it has in fact worked successfully. Now the webhook is just one way that you can automate this whole process. You could also use something like a schedule if you would prefer to maybe build this image nightly if it's quite a large image, rather than doing it every single time there's a change. Perhaps you want to just do it once the day's ended, all those changes have been made, and you build one image every day, maybe a nightly build that you want to publish. Now, if you do want to publish to registries, you can also do that inside of Kestra. Now, similar to last time, we've got that working directory, which we can see on the right-hand side. I can actually open it up a little bit easier to see here. The tasks are very, very similar. We've still got the working directory. We've still got our clone task, followed by that build, and then the run. The key difference here is, inside of the build task, I've changed a few properties here. First notable change is I have changed my tag to be for the GitHub container registry by using the namespace here, which is my GitHub username, and then the image tag that I want to use. In this case, I've just named it Docker example, as that's the repository that I've been using. I've then also added labels here, which allows me to then link it to a repository. And I've also just added a description just so it's a bit clearer on what's going on. Now we add this extra field here called push, which means it will push it to our registry when we build this image, whereas before it was just building it locally, but it wasn't trying to push it to a registry. And then we've just passed it some credentials. Now this obviously works with other registries too, so you don't have to just use the GitHub registry, you can also use Docker Hub, for example, and other popular registries. Now, at the end here, we are running it again, but we could just decide not to run it. In fact, I'm going to remove that run task because all we want it to do is build this and push it to GitHub. Now, I've actually already done this once before, so you'll see that the repository itself already has a package. But if we have a look here, we'll see that if I was to copy and run this, it will just currently say hello world because I haven't published a new image. Now the Docker file has changed in our earlier example. So let's run this now and we'll see it upload a new change directly to GitHub, ready for our users or whatever to pull. Very useful if maybe you want to publish a new version of your product, and you can use Kestra to automate that build process so that you haven't got to do it yourself. And as we can see here, it has successfully built it. If we go back here, it says last published 30 minutes ago, but if I give this a refresh, we'll see less than a minute ago, it has published a new version of the package. So now you can pull this image from the GitHub container registry and run this in whatever scenario you would like to do. Now, our next example is on a similar sort of trend of being able to help automate that sort of publishing process. But in order to be able to publish images successfully, it's best to run some tests to make sure that your images are running successfully. And I'm going to use Kestra as an example here. We have loads of plugin templates, and before we package these up into Docker images and ship them to Docker Hub for users like yourself to be able to access, we like to just double check that everything's working as expected, so we aren't pushing broken changes into our stable releases. So we've got a full test suite running, and we've got a template repository here that luckily these tests are quite simple and don't require loads of credentials, so I'm going to use that for my example today. Now, what I can do here is now I can clone that repository rather than cloning what we were before. Last time I was using the Docker file cloned from GitHub, but because we don't actually have a Docker file, we just have a test suite using Gradle, I'm going to just build a Docker image using the tools I'm going to need. In this case, I'm just using an ellipse image, which will have all of those Java build tools that I need to be able to run this test suite. And then because I'm using the working directory, I can easily copy that repository inside of the image here, and then I can run the Gradle test suite. What it will do is it will build that image, and then we can run it and we'll see it run all of those different test suites. And the best bit is because it's using a webhook trigger, this will happen every time a new change is made, so we can see if those changes were successful or if they weren't. Really, really handy for being able to just check if things are breaking, because you'll be able to spot very quickly where it started to break, and that will probably tell you what change is causing the issue. Now, there's another way that you can actually build and run the tests using Kestra. Now, similar to last time, we can build the tests using the same Docker build task, but instead of adding all of those running commands to run the test suite in the Docker file, what we can do is actually use a shell commands task here with a Docker task runner, which means it's going to run our commands inside a Docker container, and we can just specify that it should use the container we've just built, which means it's going to have access to all the Java tools that we want it to. It's going to have the repository inside the container, so we don't have to clone the repository again. And then it means we can just run whatever commands we like. I prefer this option. I like the way this works. I think it's a little bit cleaner than using the other way, which is to put all those commands inside the container. Instead, we've got an image with the environment set up, and then we can run those tasks inside of shell commands task here. And so I could add later tasks, I could do other things. And the thing that's nice is that repository is already cloned in the image, but I could also not clone it if I wanted. I could just clone it as part of this task too. So there's loads of flexibility here on how you want to best set up your CI/CD pipeline. I'm going to run this workflow just so you can see what this will do. So if I press execute here, what you'll see here is it's going to build that container, and then that shell scripts command task here can start using that container with the image already. We can see here that that shell commands task is able to start running the Gradle suite here, and it didn't have to download all of those build tools. It just had a Docker image that was all pre-packaged with the repository already in it. Now, obviously, this is quite a straightforward example so that hopefully you can understand how it works. But if you're running something way more complicated with Docker images with loads of dependencies, this could totally streamline your process by being able to package that environment up and then hand it over to a shell commands task to run a load of shell commands as you wish without having to deal with the dependencies. So as you can see here, the tests have successfully passed. We can see here that the build was successful. So the task itself has succeeded. So we can see the workflow succeeded. If you weren't as lucky as me and your tests failed, what you can do is use this errors block here, where you can put a number of tasks of your choosing to run if the workflow fails. And so you can see here from the topology view, if it fails, it's going to run this log task. Now you could change that for a notification like Slack or PagerDuty or anything like that, so that you can get notified in the best way for you, so you can investigate. But if I was to have it fail, for example, I could just put at the top here, exit with a code 1. We can just run this again and see that what it will do is it will fail, and instead it's going to run that log to let us know that it's failed, and it's going to finish with the failed state. So you can set this up so that if it does fail, it will notify you, but otherwise it can continue to run in the background and only bother you when it's important. So hopefully this has helped you understand how you can automate your Docker builds and tests with Kestra at the core of the operation. If you enjoyed this video, make sure to subscribe to the channel. This really helps us out a load. And if you like the project, make sure to give us a star on GitHub.